All right, hello everyone. Welcome to part two of simplifying with negative exponents. So we've got an expression here that looks a little tricky, a lot of stuff going on. I'm going to break it down for you piece by piece and go through all the steps necessary to simplify this. So the first thing I look for is if I can add any Ninja 1 exponents. And I see right here that I can add a Ninja 1 right there. And then the second thing I notice is that this is not currently expressed as a fraction. And you know me, I love fractions, so I'm going to go ahead and rewrite this as an extraction, excuse me, as a fraction all over 1. Anything divided by 1 is equal to itself, so that's why that's a legal mathematical move. All right, my next step to simplify this, sort of similar to order of operations, is looking to apply my exponents. And again, I've got this negative 2 up here. So I'm going to go ahead and circle that and draw an arrow to each of the exponents inside of my parentheses. Again, you're you're only applying that, okay, to the base values that are inside of your parentheses. Okay, so again, that's why I'm not drawing it to that x squared, which is outside of the parentheses. All right, and again, a power to a power rule. When I'm raising a power to a power, I multiply my exponents. So this is going to turn into, now the x squared did not change, right? The x squared did not change, and I'll even keep that as green. The x squared did not change. Now x to the first raised to the negative second. Again, doing negative 2 times 1, that's going to give me, we'll do this in a different color, that's going to give me x raised to the negative second. And then here, negative 3 times negative 2, again, that's just multiplying negative 3 times 2, which is going to give me y to the positive sixths all over 1. All right, now my next step is to simplify even further. And I notice here that I am multiplying the same bases in my numerator. Okay, I have an x raised to the second and an x raised to the negative second. Again, they have the same base, they have that same base value. So I'm going to apply my product rule, which means adding the exponents together. Okay, adding my exponents together, which in this case, after I do that, is going to leave me with x, 2 plus negative 2 is actually 0, all raised, or excuse me, times y to the sixths all over 1. Now, at this point, okay, would be a good time to introduce our last exponent rule. I shouldn't say last, but the next one we utilize very heavily, which is the 0 rule, which means anything raised to the 0 power is equal to 1. Okay, anything raised to the 0 power is equal to 1. So this makes our job pretty nice. X to the 0 power is just equal to 1, and then times y to the 6 all divided by 1. And at this point, 1 divided by 1 is 1. We can kind of just get rid of that, all right? And we can leave it as y to the sixth. Okay, so again, what we did here, we started off with this expression way up here, lots of different moving pieces going on, and then we realized, oh, when we apply our exponent rules, it simplifies down to this part right here, and then we talked about how anything raised to the 0 power is equal to 1, and then we simplified it even further. Okay, we'll go through another example of this in our next video. Thanks, bye.